Okay, for the first part of the video homework, let's talk about problem 1. So problem 1, we have a joint density function as this. And the definition region of x, of y. Alright, so the first question is that we need to find an A so that the density function here is a valid density function. So according to the definition, we know that we have the equation like this. We should do the integral of this density function, and the result should be 1. And after some calculation, we know that it's 4 over a equals 1 and a equals 4. Okay. So next part, let's talk about the question 2. So question 2 is asked us to find if x and y are uncorrelated or not. Okay, so if we want to know these two random variable, if they are correlated or not, we have to find the two expectation, the expectation of x times y and the expectation of x and the expectation of y. Right, if expectation of x and y equals expectation x times the expectation of y, then we know that it's correlated. Right. So first let's try to get the expectation of x and y. It should be like this. The definition region of x and y separately, and xy times density function. And we know that this is 1 over 9, and the expectation of x equals x times density function we got 0, and it's obvious that the expectation of xy does not equal expectation of x times the expectation of y, so they are uncorrelated. And the third question asked us if they are independent. So if we want to know two random variables, they are independent or not, we need to find their density function, right? So if the joint density function equals the product of two density function, then we know that they're independent. So we have to get the density function of x first. It's joint density function, it's integral to y, and it's 1 over 2, and of y integral over x is also 1 over 2, and definitely this equation is not a equalization, so they're not independent. Alright, and the fourth question. first question, we need to find the joint density function of x to 2 and y to 2. It's easy if we take this into z equals x squared and w equals y squared. We can have the Jacobian matrix as this. Right. So, and we know that there are four solutions to this function, and it is like this. X could be v, y could be w, x could be minus v, y could be minus. They're all minus. Okay. So the joint density function of x squared and y squared should be the sum of four solutions, right? So we got an over Jacobian, the absolute value of Jacobian, and it's 4. So we have, okay. So finally we can have the joint density function of x squared and y squared as this. Last question, question 5. We need to prove or disprove that x squared and y squared are independent or not. Yeah, as the same as question 3. We need to make sure if this joint density function is the product of two density functions. And it's obvious because the joint density function right here, it can be written in a way of like part of the function of d and part of the function of w, right? It can be right over, for example, it can be right over like this. It can be written like this, 4 times v. So this is the density function of w, and this is the density function of z. So obviously they're independent. Alright, that's all about the problem 1.